Hello, I'm Robert Randall, often called Sandy, and with me here is my wife Carol, who encouraged and helped me at every step of the way. We built our zero-energy home to be our retirement home. My saga started during the fuel crisis of 1973, when I began to think about how to reduce my dependency on heating oil and make a super efficient house. It was frustrating how hard it was to find good technical information on solar energy. I struggled through several design concepts, and it was not until 1999 that I was able to glean enough facts to feel confident about setting out to build a zero-energy home. The original sketch design was pretty much the same as what I ended up building in 2006. I had to take a course in AutoCAD computer drafting to be able to turn those sketches into detailed construction drawings. The challenge is actually pretty simple. Provide enough sustainable energy to offset total energy demand of the house. I dismissed wind energy because our location has insufficient wind resources to be a practical part of the solution, so I chose to go with solar power. In 2006, solar power was far more expensive than today, so it made sense to try to make the energy demand as small as possible. It still does. Energy conservation is cheaper than energy production, and the design features aimed at reducing energy demand, that is, heating and cooling loads, have the secondary but very important benefit of making a house more comfortable year-round with desired temperatures distributed uniformly through the house. The construction incorporates SIPs, structural insulated panels with a thick core of foam insulation. I chose 8-inch panels in the walls and 10-inch panels in the roof. The thick panels led to wide windowsills, which Carol loves for accommodating her indoor plants. The windows were chosen with care. Expensive triple glazed windows reduce the winter heat loss and summer heat gain to a small fraction of the heat loss or gain of traditional glazing. Awning-style windows provide maximum unobstructed view and minimum air infiltration, otherwise known as drafts. 2/3 of the windows face south for maximum passive solar heating in the winter. But the liability of summer solar heat is real, so the windows are sized and situated so that in summer they are shaded by architectural projections above. On the main floor, the shading is provided by carefully designed roof overhangs, and on the lower floor by a projection of the floor above. In the summer, no direct sunlight falls on these windows. This is very important in keeping cooling loads to a minimum. Likewise, the 10-inch SIPs on the roof keep the heat build-up to a minimum. With all these energy conservation features, the heat loss in the coldest winter weather is about 10,000 BTU per hour, about 1/10 of the heat loss of a conventionally built house of the same size. The energy demand of appliances is of course part of the picture, and an electric stove, electric clothes dryer, and electric water heater all contribute to the total energy demand. The house is heated and cooled by a geothermal heating and cooling system, more correctly described as a ground source heat pump system. My calculations suggested a heating and cooling load of 1 ton, or 12,000 BTU per hour. The availability of suitable high-efficiency equipment led to the installation of a 3-ton water furnace geothermal heat pump, water to water, with 3 200-foot wells in the ground loop. It runs about 1/3 of the time in coldest weather. Heat is distributed by radiant floor heating, incorporating PEX tubes embedded in a 2-inch topping slab over the 8-inch hollow core precast concrete plank deck, which supports the main floor. This construction provides a very large thermal mass to absorb the incoming passive solar energy on sunny winter days and release it slowly during the night. With the radiant floor heat, you can walk around barefoot all winter long in complete comfort. We installed a small high-efficiency wood stove as a backup heater and also for the nostalgic pleasure of having a small fire on a cold winter night. When using the wood stove, the geothermal heat has to be set down to avoid overheating the house. Interestingly, the radiant heat of the main floor also radiates upward and downward to heat the downstairs and the upstairs. We call them by those names because the downstairs, while actually being the foundation level, is by design comfortable living space with half of the south-facing windows, making it bright and cheerful living space. As we set it up, the downstairs houses the library with big screen TV as well as the guest suite. 2-ton chilled water air handler, also by water furnace, hidden in a closet upstairs, provides the air conditioning for the whole house. Calculations suggested a 1-ton unit, but equipment availability led to the installation of a 2-ton unit, which predictably runs only about half of the time. The geothermal system has 2 features which I consider to be pure serendipity. The first is the de-superheater, which delivers a stream of waste heat via hot water to a preheat tank in a domestic hot water supply, providing hot water feed to the electric water heater, thereby reducing the amount of electricity used. The second bit of serendipity relates to the seasonal thermal cycles of the ground loop with its 3 200-foot wells. During the winter, in heating mode, the wells draw heat from the surrounding earth, chilling it by several degrees as the winter goes on, creating deep cylinders of cold earth. When cooling season arrives, the process is reversed and the heat pump dumps heat into the same earth to cool the house. As the cooling season progresses, the earth becomes a heat sink and warms substantially, thus providing significant added efficiency to the following heating season operation. Over the first year of operation, the net increase in electrical consumption turned out to be the equivalent of a $400 annual cost for heating and cooling the entire house. That surprising result was probably due in part to the reduction in the electrical use for domestic hot water. The heat pump heats or cools, depending on the season, water in the geothermal buffer tank.